Hi everyone. Okay, we're finally going to get to basically what's the equivalent of Calc 1 shortcuts in Calc 2. Unfortunately, they're tricky. They're not super straightforward like some of the Calc 1s, although I would say substitution is not anything too crazy. So I have a preview activity just to get you going. Substitution is a trick for reversing the chain rule. So I want us to start with remembering exactly what the chain rule looks like. If you are trying to take the derivative of a composition, and usually we call it, I'm even going to change my mind here, f of g of x, not that it has to have a specific name. It would be good. I've been trying to retrain myself. Usually you'll see it as u substitution, so if you watch other videos, it's very likely they'll call it that. I find that that gets a little confusing when we do integration by parts, because in integration by parts we have u's and v's that we use. So I'm going to call it w substitution, but use whatever you want. So I'm naming this inner function w, and that's very deliberate because our goal later will be to substitute w. Okay, so pause, work through this. I want you to find derivatives using the chain rule, and then see if you can work your way backwards to antiderivatives. So, differentiate. Okay, so here's the Calc 1 part. So if we're going to differentiate an exponential function, we would get the exponential function multiplied by the natural log of the base. E is the special one because the natural log of e is 1. But then we don't just have e to our variable, we have e to a function. So the chain rule says you have to multiply by the derivative of that function. So in this case, this is our w of x. So we get 3e to the 3x. So that's a nice easy chain rule. We've actually guessed our way backwards out of some of these already. It's pretty easy when you're just composing with a linear function, so that the only thing the chain rule does is pop out an extra constant. Okay, so for second one, h of x equals sine 5x, still a pretty simple composition. The outer function is our sine, and then the inner stuff, whoops, sorry, that's super messy. 5x plus 1 is our w of x. So the derivative is going to be the derivative of sine, which is cosine, evaluated at w of x, which is 5x plus 1, multiplied by the derivative of w, which is just a 5. You don't have to rewrite these, but I certainly like it better, so I'm going to. Okay, again, pretty simple. It's a linear function. We just get an extra constant. In fact, it looks like I kept all of these pretty simple just to get us going, but we will do messier things. If we want to take the derivative of arctan of 2x, arctan is our f, 2x is our w of x. So we will say the derivative of arctan is 1 over 1 plus stuff squared. Our stuff is a 2x. And then we have to multiply by the derivative of w, which is 2. So we have 2 over 1 plus 4x squared. And then the last one, we have, okay, so this is a little trickier to write. This is our w of x. Our f of x is an x to the 4th. So not so terribly tricky to take the derivative of, but not quite so easy to label as the last couple. The derivative of q is going to be derivative of f, which is 4 times stuff cubed, multiplied by the derivative of the stuff, which is going to be a negative 7. So I get a negative 28 times 2 minus 7x cubed. Okay, so now that was the Calc 1 practice. Now we want to try and use that for some Calc 2 thinking. So again, we've already done some of this, so this is just our warm-up. We would like to look at what we've done and use it to find some antiderivatives. So if I know that the derivative of e to the 3x is 3 times e to the 3x, then the antiderivative, so we'll call it big G, of e to the 3x should be e to the 3x over 3. The thinking here is that when you take the derivative of the top, you're going to get 3e to the 3x. So this is the derivative. And then when we divide that by 3, we'll get back just plain old e to the 3x. I want to point out, because this is a really big mistake that people make when they're getting started on this, the only reason this is so simple is because dividing by 3 doesn't force a quotient rule or anything weird like that. It's just a constant multiple. So this is the same as 1/3 e to the 3x. That's why it's so easy when you're just chaining out a constant, because it's really easy to cancel out a constant. If you're chaining out variable stuff, not even close to as easy. Okay, so cosine of 5x plus 1. We already know that the derivative of sine 5x plus 1 is cosine 5x plus 1 times 5. So here we know that we better have that sine 5x plus 1, but we know if that's all we use for our big H of x, then its derivative is going to give us that extra 5 out in front. We don't want it, so we're going to, here I'm going to sneak it in front, divide by 5 or multiply by 1/5. I'm going to write it as the 1/5 because people tend to make things harder than they are when they write it as a quotient and forget that they can just move that out in front. P of x. Okay. I don't know if I actually like my naming here. But new problem, so it does relate back to the P of x we had last time. So this looks a lot like the derivative of arctan 2x. I just don't want the 2 in the top. So I'm going to say if I want to end up with this based on above, I think I should start with an arctan of 2x. But if I only started with arctan 2x, I'd have the extra 2 on top, so I'm going to multiply by 1/2. And again, on any of these, your check would be to take the derivative. So I would have 1/2 of 1 over 1 plus 2x squared, and then I chain out an extra 2, and you can see those 2's canceling, and I will get my 1 over 1 plus 4x squared. Okay, last one, if you're going to start with a 2 minus 7x cubed, we know that if we take a 2 minus 7x to the 4th and take its derivative, we'll get that 2 minus 7x cubed, but we'll have an extra negative 28 carry along from the chain rule and the power rule. So here, I'm going to say that I want 2 minus 7x to the 4th, and I want to multiply that by negative 1 over 28. So when I go through my check, the power rule says you're going to get negative 1/28 multiplied by 4 times 2 minus 7x cubed, and then the chain rule is going to give you that extra negative 7. So the minus signs will cancel. 7 times 4 gives me 28, so that will cancel, and there's my 2 minus 7x cubed. Okay, so there's a little bit left to this preview activity, and that's now that we've practiced a few of these where we can see that it's pretty easy to guess your way out of a chain rule if you are only chaining out a constant. This just gives you a few more to try. Okay, so looking at this, if I want to work my way backwards out of this one, I'm going to say, well, if I want to end up with a cosine, I better have started with a sine, and the only way that pi x is going to be in the derivative is if it was in the original function. But when I go to check, the derivative of sine is cosine, but then the chain rule says we have to multiply by a pi. So I'm going to want an extra 1 over pi out in front. And looking at this, what we're seeing is that sine x is our f, and pi x is our w of x. Okay, if we start with 4x plus 7 to the 11, I can guess that the only way I ended up with stuff to the 11 is if I started with stuff to the 12. But I know that when I check, I'm going to get a 4x plus 7. So I'm going to get a 12 times that to the 11, and then I'm going to chain out an extra 4. So if I don't want those things to show up, I'm going to need to divide by 12 and 4, which is 48. So now, these will cancel out. Oh, I might sneeze. Oh, and up here, when I throw in the 1 over pi, that canceled those out. Okay, so here, this tells me that my f of x is x to the fourth, and this is my w of x. All right, last one, n of x equals x e to the x squared. This gets a little trickier, but substitution will help us with these a lot. So let me do a little side note here and say that if I started with, we'll just call it something else. What have we used? If I started with g of x equals e to the x squared, the derivative of e to the x squared is e to the x squared times 2x. So if I look at what I actually have right here, it's really similar. I just don't want the 2. So for this guy, I'm going to say big N of x should involve an e to the x squared, but if I don't want that extra 2 showing up in the derivative, I'm going to need a 1/2. So here, I'm seeing that, this is giving me my f of x is an e to the x, and this is my w of x. Okay, so now what we're really wanting to do is be able to not look at the answer that I've already figured out and pick out f and w, but actually look at the function I started with. So if we're thinking about, in fact, this last one is really the only good example of this. If we're thinking about looking at something and trying to reverse the chain rule, what we really want to see is the f of x, f prime of x, the w of x, and the w prime of x floating around. So let me scroll for just a second. Okay, so back up to here, we're trying to look at here, look at this, and work our way backwards. So the easiest thing to spot often is the w and the w prime floating around, and then you can just separate out the f prime from all of that. So if we can look at this, where'd it go, and say, well, I'm seeing a w of x in here. This isn't exactly w prime, but it's really close. It's only off by a constant, which I know is easy to fix. Then the goal is just to say, okay, what's the antiderivative of the f prime, and then stick the w back in there. That's what the substitution rule does for us. Okay, so we'll work on that next.